What is relativistic speed? When two particles of a certain mass are moving at, let's say, 99.99% the speed of light, anti-parallel to each other, which means in this direction coming towards each other, the relative speed shall be more than the speed of light. Are you sure? So the question is, how does relativistic speed justify Einstein's special theory of relativity? You need to study Einstein's special theory of relativity, uh, Lorentz transformations, relativistic velocity addition, all that, and you will see it's not the case. Even if two particles are moving at the speed of light, if two photons are moving towards each other at the speed of light, so this guy is at the speed of light, this guy is at the speed of light, and if I'm sitting here, I will see the other guy coming to me not at twice the speed of light, but only at the speed of light. That's how velocity addition happens in special relativity. So let me show you how this works. Let me demonstrate what it is. Let me share my screen. 1 second. Give me a second. And I will actually try and demonstrate this. So to understand this, I cannot explain this to you in a way that makes sense intuitively. Relativity doesn't make intuitive sense. Quantum mechanics doesn't make sense from an intuitive perspective. So let's talk about the velocity addition. So this is the formula that governs velocity addition. We are applying the Lorentz transformations to the velocities, right? So you have something that's coming in one direction at 0.8 times the speed of light, and the other one is coming at 0.9 times the speed of light. And then yet when you add it up, it doesn't add up to 1.6 times the speed of light. So let's go to basic application. Okay. So relativistic relative velocity. There is VA and VB in two different directions. Let's say you are saying that VA is 0.99 times the speed of light. I am entering that. And VB in the opposite direction is minus 0.99 times the speed of light. Then what you get is 0.999999494, whatever, C. It doesn't add up to 1.8 or whatever times the speed of light. It does not. It adds up to less than the speed of light, even though both are almost at the speed of light. So that's how it works. You have to study the equations. You have to study the theory, and then you will realize it's not quite the case. So you can look it up. The mathematics is quite simple, actually, compared to the general relativity mathematics. So that's how it works. So to understand how these things work, you have to actually study the physics, study the math. I can tell you, but you won't believe it most likely because it doesn't make sense to you. So unless you go deep into the physics and you actually study the equations and how they are constructed, how they are derived, only then will you understand. But that's how it works. The cosmic speed limit is the speed of light. Nothing can travel faster than the speed of light. And if a particle has mass, it cannot even reach the speed of light. It will always be below the speed of light. And there are all these relativistic effects like time dilation and so on and so forth when it comes to these phenomena.